And we'll move on to the next presentation, which is Professor Debole Chakrabarti from India, from IIT Kharagpur. I see you're ready to go, Debole, so please take it away. Thank you.
Yes. Yeah. So is my screen visible to you all?
Yes, that's fine. We can see that. Thank you, Debole.
Yeah. Okay. Okay. Thank you. So it's on the development of high-strength vanadium microalloyed structural steel. Because now whatever structural steel being made by Steel Authority of India Limited, who are the collaborator of this project, and I am from an academic institute called Indian Institute of Technology in Kharagpur. So they do not use the microalloying so far in their structural steel products. So both for structural section and structural plates, this project has been taken, and this project is going to be over by the end of this year. So we studied the effect of composition, primarily carbon, vanadium, and nitrogen, and how far we can reach. Because now I think they are making up to 350 grade, which we want to enhance. So what we have done with this background, so the required properties are tensile properties, and impact toughness is a very important property, because nowadays in India also steel being used in cold terrain, where a good impact property at low temperature is important. And we know that niobium has several issues for which vanadium is preferred. So far, all these steels have been melted in the pilot scale plant in SAIL, in their research center in Ranchi. So it's not an academic lab trial, rather it's a more pilot scale trial throughout this project. So initial few grades, we have some problem with high aluminum content, which later on we managed. And all these green grades I have presented last time, and these blue grades are presenting today as the new addition. So you can see the composition. We are varying vanadium almost over a wide range. So accordingly, naming the steel as L for low carbon, low vanadium, M for medium vanadium, say 0.04 is our medium level, and another is high, H vanadium, that is 0.0809 is our high vanadium. Similarly, we have varied nitrogen level. These steels are having quite high nitrogen. You see 196 ppm, 191 ppm, and we are using the nitrovan that Vanitec has provided to the R&D center of SAIL. So we are rolling them into two thickness plates, 12 mm and 25 mm, and studying the properties. So with this, if you have gone through the chemistry, in certain cases, we got last time a little low carbon level, but high vanadium and nitrogen level. So this steel is interesting to look into. This time we have managed to increase the carbon level to from 0.01 to 0.04, because structural steel generally have carbon in the around 0.15. So we were quite happy with this composition, but I am showing the further things. So these are the thermocalc predictions. So naturally the steels where we have added more vanadium and nitrogen, naturally the precipitation temperature has gone up to about 1100 degree and like that. Going to the next slide, if you see here, the precipitate temperature and precipitate fraction we are showing, mostly vanadium carbonitride precipitates that we are expecting. These two I have marked in blue because in the presentation that I shared with Dr. Dev a few days back, these calculations were wrong, because what happened that we have dragged these temperatures a bit high, so zero values were come. So these are the actual precipitation start temperature for this grade, 1020 and 1128. Still 1128 may be considered a bit at the higher side for this high carbon, high vanadium, high nitrogen steel. These are the microstructure that I presented in the last meeting, which were rather good, quite fine microstructure with grain size in the range of 8 to, let me minimize it, yeah, 8 to 10 grain ferrite grain size in that range. So these are, the previous slide was for 12 mm plate, this slide was for 25 mm plate. Where the grain size was little higher, of course, because of the larger thickness and lesser rolling reduction. This time, one issue happened with us that our grain size was relatively higher. You can see 13 and 18 in that range. So grain size problem we would have loved to have a smaller grain size, possibly. As I talked to my collaborators, Dr. Kumar and Mr. Aniket at SAIL, they said that the furnace temperature was a bit high, and it was behaving a bit erratic because it was newly installed. So that and rolling schedule also, there may be some issues for which grain size is a little higher. So, so you can see the last time, these are the EBSD maps I have presented. And this time, these are the EBSD maps. So you can see the grains are slightly higher, but it's a nice ferrite perlite microstructure altogether. Overall, these were the tensile properties. Last time, these were the properties that I presented here. These were low carbon, high vanadium, high nitrogen steel, which showed quite a high strength. You can see the yield strength level very conveniently more than 450 MPa and even crossing 500 MPa. This time we got a good strength in our high carbon, high vanadium, but strength were not that high, maximum around 460 MPa strength we got. And in this steel, high carbon, medium vanadium, it's around 400, the yield strength. Rest of the properties are good because it's showing nice tensile curve as expected with quite a good amount of elongation. So these are the properties you see, the strength level. These are the good properties indicated as green, and blue is even higher. So these are the new casts. So here the best properties we got in this high carbon, high vanadium, high nitrogen one, 460, 464 crossing. So, and these are the UTS values. Uniform and total elongation, we are reporting yield strength comfortably less than 0.08. So it must be having a good bendability and other properties. And these are the properties last time I presented. In some of the cases, it was crossing even 500 MPa. So these were the properties. So overall, I would say that a good variation happened in composition, in processing, and we have seen our best case scenario as well as worst case scenario. And in all cases, what is the range in which we can get the properties? So composition as expected increased with carbon, vanadium, and nitrogen. Nitrogen, of course, is very beneficial in vanadium containing steels. As we have seen, even at low carbon level, we have got very good properties. But this time carbon gone a little higher, but we are not getting that much of benefit. In both steels, there were vanadium about 190 ppm, more than 190 ppm. So overall, the expected trend that we have got, these are the impact properties at plus 25, 0, minus 20, minus 40. Last time we presented impact properties only for the transverse sample, and we received a suggestion to perform impact testing at longitudinal sample also, rolling direction sample also. So this time for all the steels, we have done that. And we can see the longitudinal results are much better than almost double in some cases than transverse properties. And in all the blue cases, we are exceeding the toughness more than 27 joule, which is minimum required for structural purposes. So overall, we are meeting our properties, and we have found a good range of properties for all our compositions and products, and even for thicker plate, 25 plate. Of course, few exceptions are there where we have got a little less property in longitudinal direction, which we have to investigate. But otherwise, it's quite a decent result. So these are the transition curves for high carbon, medium vanadium. It's a more sharp transition, whereas in high nitrogen vanadium steel is a more gradual transition. So overall, these are the properties, and these are the minimum required level, and several data are lying above the minimum required level. Here, plotting all the yield stress and impact toughness of whatever steel we melted under this project, and all these results are all satisfying either 410 grade. Yellow color represents 410 grade requirement, and green is 450 grade. So in many cases, we are exceeding the 410 grade and 450 grade, as I will show in the conclusion section also. And fractography study has also been performed, and as expected, some amount of ductile fracture. These are the minus 20 tested specimens, 0 and minus 20. Even there, we have found some amount of ductile fracture before the cleavage fracture happens. So then this is the conclusion that naturally this is expected that increasing these elements will improve the property. In some of these grades, we exceeded 350 requirement. In 12 thick plate of low carbon grade, we fulfilled 450 requirement with a very exceptional property. And in this grade, we exceeded 410 requirement. And even this time now, high carbon, high vanadium, we satisfactorily meet, I think, this one 410 grade for 25 plate and 450 grade for 12 plate. So overall, these are the findings, and we have characterized the precipitates, and this process is going on. Nice interface precipitation. These are some of the images. So you can see in this low carbon, high vanadium, high nitrogen, these are there. So nice interface precipitation of vanadium carbonitride as we expect in this kind of steel during transformation. Sometimes we have found some elongated kind of features also. We are studying whether these are fibrous carbides or something else, but these are quite interesting to look into, you see. Or even transformation twin can happen in vanadium steel, we know. Sometimes you see here very fine needle-like precipitates. So these needs a bit more study. In the month of July, we have organized a one-day workshop at IIT Kharagpur from this project on microalloyed steel. And you can see the Vanitech logo is there as the funding agency. And this has been publicized in Twitter as well as in Facebook and Twitter of our institute. And if you click this link, you may find some of the images, pictures or photographs of this conference. And these were the guest list who presented. Dr. Dave Crowther was there as the chief guest and keynote lecture. Executive director of SAIL R&D was there. Several chief general managers and general managers of SAIL plants also from R&D. Dr. Vinod Kumar was there. And they presented their industrial experience on vanadium steel production. And some of us academicians were also there. So it has been a very good gathering involving both academic and industry people. These are our departments where the conference poster was given, and everywhere in the campus this kind of banner were displayed. These were our deans and heads, and even I presented one of the lectures. So here Dr. Dave is listening online. So there was a very good attendance and very overwhelming participation, I would say, and particularly thank the SAIL delegates, the executives who visited Kharagpur to attend this particular event. So you can see the delegates are presenting their experience on vanadium alloyed steel in SAIL plants. So overall, with this, Aniket, who is working in this project from SAIL and doing PhDs Kharagpur, he is invited to present oral presentation in the annual technical meeting, which is a big event in India every year. It happens in November month. So there he will present this work. He has also presented during this workshop. So we had a very good experience, and we thank Vanitech for the support. We are planning for an industrial trial, and I was discussing with SAIL executives today morning only. So what we need is nitrovan, because we do not have nitrovan supply. So if you can provide some nitrovan directly to those plants, and I'm sure Aniket has done some calculation for 100-ton melts, what are the amount of nitrovan is needed for the trial. So if you can provide, I think we can have a very good ending to this project, and we expect for a long-term collaboration. Yeah, thank you.
Thank you very much,
I'm done.
AA. That's a great presentation. Yeah, I hope we can carry on our association, and if you let us know what you need in terms of nitrovan, we'll see if we can help you out there. Are there any questions for AA in this presentation?
I have a question,
Yeah.
AA. Thank you for the presentation. I would just like to know what were your mill exit temperatures on these 12 to 25 millimeter plates?
Yeah, your finished rolling temperatures you were asking?
Yes.
Yes, I think it's 850 degree. Dr. Kumar, can you just, if you are there?
Yes, actually it was around 840, 850.
850, yeah.
850. Why I'm asking is, according to my experience, one ought to be getting somewhat higher Sharpie values at 0, at least, as to what you're reporting there. Quite a few of them appear to be pretty borderline in the 40 joule but below region. Our experience is we're getting at least 80 to 100 joules in that temperature range for those thicknesses, using a good vanadium nitrogen combination. I just can't remember what your nitrogen level was.
Yes,
but,
190.
Yeah, Devala, can I answer?
Yes.
yes,
Kevin, actually, these are air induction melted heats, and the enclosure level is expected to be on the higher side as compared to what we are making in the industrial scale. Okay, so once this go to the industrial trial, you'll get much better values, in terms of impact of this. Another thing is that the latest work that has been done on the high vanadium and high nitrogen steel. Actually, in that case, there was some issue with the furnace, as Devala told, and the expected, grain size actually has come over around 18 micron. That's quite high. If you go to the industrial scale trial with the structural steel, the substrate roughly around 10 to 12 micron we are expecting. And in all such cases that we are producing today, the grain size in that range. If the grain size comes down, your toughness goes up, and the inclusion level comes down in the industrial scale, this will further go up. So we are expecting around, once we go for industrial scale trial, this will be around 60, 70, 80 joule minimum.
Yes, these are, sir, open melted, open induction melting. So inclusion content is a bit high. Yeah, that may be one of the problems.
Yeah.
Yes.
No, we find excellent toughness up until 50 millimeters, really, using even conventional rolling, nothing special. So I'm just a bit alarmed at those Sharpie values there at 0, 43, 46 joules there, for example. Oughtn't be so low if having chosen the correct combination of nitrogen and vanadium. Yes. So maybe there is a pressing reason to get that nitro van you're talking about.
I think one of the reasons is that high sulfur content, or a reasonably high sulfur content. Is that correct?
Yeah, 200 parts per million. Yes.
Yes.
So I'm sure.
Certainly in our plant, actually in our plant conditions, whatever volume, the toughness is very impressive. We are getting 70, 80, even plus 100. So there is no issue with the toughness that we can get once we translate this information into an industrial scale trial. So this is primarily on account of air induction melting, where inclusion content is on the higher side, and the second is the grain size, which has come up around 18 micron, I believe. That has also resulted in the poor toughness as compared to what we get in the industrial scale.
Okay, well, thanks for that. In the interest of time, I'd better bring the discussion to a close. So thanks again, Devala. I'm glad to see this project has good cooperation with SAIL, and I'm glad to see it's progressing to industrial trials. And I'd also like to compliment you on those interface precipitation pictures. Those were really good examples of interface precipitation. So nice to see that. So once again, Devala and Dr. Vinod Kumar, thank you very much for your efforts.
Thank you
for this.
Thank you. Okay, if we can move over to the next presentation.